Hi, my name is William Few, and I'll be representing Group 1 in this video update of our progress on Project 3. This is our first video update, and over the past few weeks we've had to learn to come together as a team, and I think overall we've gotten past the friction that comes with the initial stages of team building. In the first two research projects, we first had to get familiarized with XPC Target and Simulink. But once we overcame that obstacle, I feel like we progressed well and achieved very satisfactory results, and I think we're ready to move forward on Project 3. The first challenge that we had to overcome in Project 3 was picking the basic design for our robot. The different options we had in front of us included a gravity-fed system, an air pressure system, and a system that uses mechanical wheels to propel the ball towards the target. We considered both the gravity-fed system and the mechanical wheel propelled system, and we ended up deciding on the mechanical wheel position system because it's something that we were familiar with programming as far as control systems, and also Group 14, the team that won last semester, had tremendous success with that kind of system. But a little bit different from Group 14, we're going to implement a panning base that will aim our target through rotational motion, as opposed to Group 14 that used relative rotational speeds to put spin on the ball and hit the targets. We feel like this overall will be easier to program, and it will also provide for more accurate results over the long haul. But with this choice came additional new problems. For example, a simple servo doesn't have the torque nor the mechanical integrity to support our robot and rotate it, primarily because we plan on building our robot out of steel, so it could be up to 50 pounds. However, our research has found that Servo City and some other robotics part suppliers sell gearboxes that you can attach to a standard servo that convert the output shaft in a 5-to-1 gear ratio, which more than triples its torque, and they claim it can support up to 200 pounds and complete 60-degree rotational turns in under a second. This would fit our needs because I don't think our robot is going to be over 200 pounds. It would be much less than that, actually. And also, we determined through our research that we only need 50 degrees of turn in order to hit all the cups on the board. So that's one option, but the downside of that option is that it's going to cost $60 for the gearbox ratio converter, and also there'll be an additional $20 for the servo, so you're talking about $80, $87. That could be up to 30% of our total budget. Now, moving forward from there, we're going to have to combat the issues of image processing and also fabrication. As far as image processing, we're not quite sure yet what the process is going to involve when we try to take a picture and then process it through Simulink and MATLAB and try to come out with a program that can find differences in the two images quickly. Because the whole thing is under a time limit, and we have to be able to perform when the light goes off. So that's going to be an issue that we're going to have to research further and come up with a scheme. Also, as far as fabrication, we want to use steel, and challenges come with that are beyond working with wood or PVC. We're going to have to either bolt the things together or weld them together. But I think we're going to have use of a laser cutter system that will take CAD drawings from our computer and cut our designs out of sheet metal. That, in combination with angle iron, we should be able to create all the pieces that we need for the structure of our robot. So with those tools and what we've learned so far, I feel good about our progress in this project. I wouldn't say that we're ahead of schedule, but I think we're on track for a competitive robot. And I think I speak for everyone on my team when I say we're excited about actually getting our hands dirty, getting in the shop, putting everything together, and going after the other teams. Thank you.